In the second questions, we have been given two independent standard normal random variables x and y, and we have to determine the PDF of W, which is equals to the square of the random variable x and the square of the random variable y. First things first, we know that from theory that if we take a standard normal random variable and we square it, we find a chi-square distribution with 1 degree of freedom. Okay, now in this question we are not going to use the standard normal random variables. We are going to use a chi-square distribution with 1 degree of freedom, since it is a square of the standard normal distribution. Okay, we also need to find the mean and variance of another random variable u, which will also be a transformation of this random variable we are firstly going to find. So let's get into the question. So first things first, all we need, okay, the PDF for our x squared, which is the standard normal random variable that was squared. So it's going to be 1 divided by 2 square root of 2 pi. This is the chi-square distribution with 1 degree of freedom. Now this will be x into the exponent of negative a half e raised into negative x divided by 2. This will be the square now of our random variable x. This will be the PDF. Now for our y, we'll have the very same thing, just the change of variables. This is y divided by 2. Now, if we take a look at this question, we have a summation of two random variables. So if we add two random variables, we can either use the convolution method of transformation, or we can use the transformation method using the method of moment generating functions. That is the method we are going to use in this question. So we're going to transform the random variable w using the method of moment generating function. So w is going to be equals to x squared plus y squared. I don't think it is really much relevant to call these random variables x and y, since they are also a transformation of the standard normal distribution. So I'm just going to use two new random variables. So this one is going to be u. I'm going to use u and v for the chi-square distribution so that I don't confuse you with what I'm saying. Okay, so this will be u u and then v divided by 2. So u and v are now the squares of our random variable, which was a standard, the two random variables which were standard normally distributed. This is the same thing. So if I say u plus v, we are still talking about the same thing, because now it's no longer a standard normal distribution, it's now a chi-square distribution. Now we are going to use the moment generating function method of transformation. So the moment generating function of our v, this chi-square distribution, it's 1 minus 2t raised into exponent of since it has 1 degree of freedom, it's going to be negative half. And the moment generating function of u, it's going to be the same, 1 minus 2t raised to exponent of negative a half. Now the moment generating function of w will be determined by this tw. Now W is just a summation of U and V, so this will be W plus V. Okay, now this will be e raised to TW plus TV, which is the same as e to the TW multiplied by e to the TV, which is now the same as distributing the expected value both sides. Now this will be the moment generating function of W at t multiplied by the moment generating function of V at t. Moment generating function of the random variable W at t. No, I think I made a mistake here. This is our W, so it's U and V, not W. U. This is our U. So it's the moment generating function of U. So recall that the moment generating function of U is just the square of our standard normal distribution, which is now a chi-square distribution. The moment generating function of these two is the same, which is these moment generating functions, these two moment generating functions. So the moment generating function of W at t is going to be equals to 1 minus 2t raised into the exponent of a negative half multiplied by 1 minus 2t raised into negative a half. This will be equals to powers of the same base. We add the exponents 1 minus 2t negative a half minus negative a half. So this will be 1 minus 2t into negative 1. This is the moment generating function of the random variable W at t. So if this random variable W, this random variable, let me use a different card. If this random variable W has a moment generating function looking like this, so recall that a chi-square distribution is more like this. The moment generating function of a chi-square distribution is like this. The V is the degrees of freedom. So if we have 1 here, it means for our random variable W, we have this. The degrees of freedom is 2 divided by 2, which makes this to be this negative 1. So we have W is a chi-square distribution with it's a chi-square distribution with 2 degrees of freedom, and it's PDF since the general PDF of a chi-square distribution, I'm just going to use FA. It's going to be equals to or what is it? It's 1 divided by gamma of V divided by 2 and 2 raised into the exponent of V divided by 2. Now we'll have A into negative, no, it's not negative, it's going to be V divided by 2, and E raised into negative A over 2. This one, it's minus 1. So if we have 2 degrees of freedom, our FW is going to be 1 divided by gamma of 2 divided by 2. 2 raised into the exponent of 2 over 2. And then A, this would be W instead of A. 2 divided by 2 minus 1. E raised into negative W over 2. This this formula right here, it's the general PDF of a chi-square distribution. Now we are trying to find the PDF of our W, since we know that it has a 2 degrees of freedom. So it's a chi-square with a 2 degrees of freedom. So now this random variable W, a gamma of 2 over 2, that's a gamma of 1, and gamma of 1 is just 1. 1, this is 2 over 2, it's 1, so this will be just 1 over 2. And then in this case we have 1 minus 0, which is 1. No, it's going to be 1 minus 1, which will be 0. So anything raised to the exponent of 0 is just 1 multiplied by 1, and then we have e raised into negative w over 2. So fw, the PDF of our w, is actually equals to 1 over 2 e raised into negative w divided by 2. Okay, so we've transformed this random variable. Recall that we now need the bounds. We took the square of a standard normal distribution, and it is a chi-square distribution with 1 degree of freedom, and the bounds of a chi-square distribution are 0 less than u less than infinite, the same as, since u and v are chi-square distribution, 0 less than v less than infinite. So now our bounds for this random variable, since we knew that it was a chi-square distribution with 2 degrees of freedom, so the bounds are also 0 less than w less than infinite, or simply just w is just greater than 0. Okay, so if we take a closer look into this new random variable w, it's actually also an exponential distribution with the parameter beta. Now we were asked also to find this mean and variance of the new random variable, which is gonna be u. I've already used u in our expression, but we are gonna carry on with this u for, so u is gonna be 1 over 2 of w. Now don't mind this u, the u that I used here. I wasn't supposed to use random variable u. So we are going to carry on with this. So now we are going to use the transformation method, so to transform this u, new random variable u. So in this case we are going to have to find this, which is just the inverse of this. So by the inverse of this, I mean we have to solve for, or make w the subject of the formula, which is equals to w, and then this will be 2u, and then the inverse, no, the derivative of this with respect to this u, it's going to be equals to 2. So now the transformation of this random variable u, fu, will be equals to fw into the inverse multiplied by this derivative. This is the transformation method now. Our fw, instead of our PDF of this random variable w, we are going to substitute this 2u, since this is the inverse. We are going to substitute this. So we have 1 over 2 e raised into negative, instead of w we are going to substitute 2u, negative 2u divided by 2, and then we multiply this by the absolute value of the derivative of the inverse, this. So the absolute value of 2 is just 2, so this will be 2 over 2 e raised into negative u. So this random variable u has the PDF of e raised into negative u, and u is exponentially distributed with the mean of 1, or beta is equals to 1, and therefore the mean of u is going to be equals to 1, and the variance of u is also going to be equals to 1. Done.